Okay.
So, and I had a test, and I can do test corrections, and I was wondering if you can help me out with those.
Sure.
Okay. So, the first problem on the test corrections is it gives me it says solve the following systems of equation using the substitution method.
Okay.
And they give us x plus 4 equals 4y. And then the other one is 3x minus 12y equals negative 12.
When you are forced to solve something by substitution, you want one of the equations to be fully defined in terms of one variable.
Okay.
Doesn't matter whether it's x or y. Which is the easiest equation here to manipulate so that it is defined in terms of one variable?
Probably the second one.
The first one's all I got to do is move the 4 over.
Oh, that's true. Yeah, okay.
Okay, so the first one becomes x equals 4y minus 4. Now I've got that first one fully defined in terms of x.
Okay.
I'm ready to substitute it into the second one. So what do I want to write in the second spot?
Okay. Would you...
Wherever you see x, plug that in.
Okay, that, the whole,
X is equal to 4y minus 4.
Okay, so then it'll be, 4y minus 4.
And always do it like this. In other words, simplify afterwards. Don't try to simplify at the same time.
Okay.
Now notice what we have now is we have one equation and only one variable. Why?
Because you combine the two?
Well, one variable y, yeah. Wow. Hold on a second. What have they done to us here? This one's going to be 12y minus 12y minus 12 equals minus 12. That won't allow us to solve for anything.
They're asking
whether there's
to take
go ahead.
The two different ones. Take x plus 4 equals 4y, and take 3x minus 12y equals negative 12, and graph those and find the coordinate in which they intersect, but by using the substitution method.
Well, that's solving it by graphing it. Okay. In other words, both of these are straight lines. That's a straight line, that's a straight line. So I can graph it easy enough. It's basically that straight line is the top equation, and the bottom equation is, oh, I see what's going on here.
Yeah, the 2 points where they intersect.
They're the same line. There's no intersection.
So there'll be no solution?
Yeah. In other words, that's what this was leading me to, was no solution. But notice why there's no solution.
Yeah, because I put that down and I got it wrong.
Well, it may be infinite solutions, and it in actuality is infinite solutions. Let's talk about that. If I say x, ignore the problem for a moment. If I say x plus y equals 10, how many solutions does that have?
2.
Infinitely many.
Oh.
X could be 1, y could be 9, x could be 0, y could be 10, x could be minus 1, y could be 11. I could go on and on forever.
I see.
Okay? So when you have one equation and two variables, you have an infinite number of solutions. Now, if I add a second equation that is exactly the same as the first, in other words, if I just double it, I have not added any information. So just because I now have two equations does not mean I can solve it. I still have an infinitely many different values for x and y that will work. Because equation number 2 is just equation number 1 multiplied by 2. It's just a multiple of equation number 1. So it's not different.
Okay.
And so I don't really have 2 equations and 2 unknowns. I have still 1 equation and 2 unknowns. So whenever you see this, whenever you see 2 equations that are merely multiples of one another, then you know you have infinitely many solutions. Well, let's look at this first equation here. If I bring the y over and then take the 4 over the other side, what do I have? I have x minus 4y equals minus 4, correct?
Correct.
Well, there's equation 2. There's equation 1. Let me erase all this other stuff I have here.
It's the exact same thing, but simpler.
Exactly. In other words, 1 is just, equation 2 is a multiple of equation 1. Therefore, that system of equations must also have an infinitely many solutions. That's why I couldn't solve it when I went to solve it by substitution. I didn't get a solution. I got minus 12 equals minus 12. So when you can't solve it by substitution, it means something's going on. And you end up with 3 possible outcomes. If you try to solve something by substitution and it works, in other words, if it's really 2 lines that intersect, you'll get an x and a y. If it's 2 lines that are on top of one another, like this is just 2 lines that one is on top of the other. You have infinitely many solutions. And then if I were to say make that a 13 instead of a 12, well, it's impossible for x plus y to be equal to 10 and x plus y to also be equal to a different number, 9. Notice that if I had these 2 equations and I tried to solve for it and subtracted one from the other, I would get 0 equals 1. So when you go to solve a system of equations and you get one number equals a different number, that's no solution.
That makes sense.
When you get minus 12 equals minus 12, that's infinitely many solutions. When you get x equals a number, now you got a specific single solution.
Okay, that clears things up.
So I'm sorry they started you out with one that has infinitely many, because it's more understandable, this whole system of solving by substitution, if you actually have something you can solve.
Right.
Do you have another one?
Okay. Yeah, I do.
Okay.
I have a lot. Y equals x plus 2 is the first one.
Okay.
And the second one is 3x plus 2y equals 9.
All right. This does not look like it's a multiple of the first equation. I mean, the x has a different coefficient in it than the y does. So I can probably solve this by substitution, as long as it's not in conflict. And it doesn't look like it will be. It looks nothing like the first equation. So I already have equation 1 defined completely as one variable, y.
Because it's...
when I say that, I don't mean y, I mean the variable y.
Oh.
I know, that's twice that's happened. That's okay. I can see why you made the mistake, because I'm ending the sentence with y. Okay, so what do I do next? Since I have y defined as x plus 2, what can I do next?
Can you move the 2 to the other side?
No, remember we're solving it by substitution.
Oh, so would you put 1 in?
What is y?
Oh, 0, sorry.
What is y equal?
Would you put 0?
X plus 2.
X plus 2. Sorry, I forgot.
Okay,
Yeah.
so let's go to equation number 2 and substitute that for wherever we see y. Help me finish writing this.
Okay, so then it'll be 2 times, in the parentheses, x plus 2.
All right. Equals 9. Now let's solve it.
Okay.
Distribute the 2.
Okay, so then it'll be 3x plus 2x plus 4 equals 9.
Okay. Add the x.
Subtract 4.
Okay.
Or, no, sorry.
That's okay. You can do it in either order. I was just doing both steps at once.
Okay. And then you divide each. So x is equal to 1.
Okay. Now how do I solve for y?
Take 1 and put that in for x at the top.
So y would be equal to 3. So there's our solution.
Here,
X equals 1, y equals 3.
Can I write this down real
Sure.
quick? Okay.
I also am recording this, so you'll get a copy of this by tomorrow morning. I don't know if that's in time for you or not.
I don't think it would be.
Okay. That's usually what happens, and let me kind of warn you about that for the future. It always takes my computer overnight to process these files. So if you have a test on Wednesday and you have a session on Tuesday night, you're never going to be able to see a recording of it in time. So the way to solve that is to try to have your tutoring session a day and a half before your test. In other words, if we had this Monday night, you'd be able to review this thing today for your test on Wednesday.
Right.
So that's completely up to you. I mean, most of my students love having the tutoring session the day before the test. I think they think that they're less likely to forget the material if it's sooner, if it's closer to test day. But in actuality, slow and steady is the way to learn everything, as opposed to cramming the night before the exam. So just know that you won't have time to review this file by the time you leave for school in the morning. But I'll still send it to you. I mean, you'll still be able to review it if you want. All right.
Okay.
Do another one.
So I have another one. Okay. It is 6x minus y equals 18. And then the other one is 8x plus y equals 24.
Now, does this request that you solve it by substitution, or can you use elimination?
It is elimination.
Okay. This is much easier to solve by elimination. The rules of algebra say that you can add or subtract any equations. So if I have two equations, a plus b equals c, and x plus y equals z, then I can always say that a plus b plus x plus y equals c plus z. I can also say a plus b minus x plus y equals c minus z. In other words, no matter what the equations are, you can add two equations or subtract them.
Okay.
The beauty of the two equations they've given us here, the reason it's called elimination is because a variable goes away after the first step. What do I have to do to make a variable disappear here?
You would have to take away the number. You have to divide it, right?
No, just add the two equations.
Oh, okay. So would you take then?
With 6x plus 8x.
Oh, 15x? Or 14x, I'm
What's
sorry.
minus y plus y?
0.
Aha! That's the variable that went away.
Okay.
In other words, I've just solved for x. If you can get one of the variables to go away, you'll be able to solve the other variable quite easily. Now, I still have to solve for y, but I can tell from this equation that y must be equal to 24 minus 8x. Since x is 3, y is equal to 24 minus 24, or 0. So
That makes sense.
y equals 0. And just to make sure that that solution fits, it works for this equation. 6 times 3 minus 0 is equal to 18. And it works for the second equation. 8 times 3 is 24 plus 0 equals 24. So those two solutions work.
Okay.
That was an easy problem because we didn't have to manipulate anything. We were able to add the two equations and immediately a variable went away. Give me a harder one. To solve by elimination.
By elimination? Okay. This looks a little bit harder.
Okay.
It is negative x plus 2y equals 10.
Okay.
And the other one is 3x equals 6y plus 11.
Okay. In order to solve by elimination, you want to get both equations in standard form. Standard form is ax plus by equals c. In other words, this first equation is in standard form. What can I do to the second equation to get it in standard form?
Would you,
Let's move this 6y to the other side.
of the equal sign, so would you subtract it to be negative 6y?
Now it's gone.
Oh, and then you're all lined up.
Now they line up perfectly. However, what is the relationship between that and that?
They're opposites. They're negative where there's a positive, and there's a positive versus negative.
So this part of the second equation is exactly minus 3 times this. That means this number over here has to be minus 3 times that. In other words,
Okay.
I've given you a problem that has no solution.
Okay.
Notice that if let's go through it. If I multiply the first equation by minus 3, I get 3x minus 6y equals minus 30. Well, if I'm allowed to do that. The thing is that these two equations now are in direct contradiction. The left side of each equation is the same, the right side is different. That means no solution. If I were to subtract these two equations right now, I would get 0 equals 41.
But that doesn't work.
It's not true. 0 is not equal to 41, and that means there's no solution to this. Let me make up a problem that has a solution, because you need to know one. All right, I'm going to make up a problem here. 2x minus 3y equals 15. This equation is not related to this equation at all. Notice that the y coefficient up here is twice this coefficient. This is 3/2 it. So,
Okay.
I can't immediately solve this by elimination. Both equations are in standard format, but a variable will not go away if I simply add or subtract them. However, I can manipulate either equation. What if I multiply equation 1 by 2?
The entire equation?
Yep, every term in it. So it becomes this. In fact, let me write it below.
Okay.
Here's the new equation 1. I'm multiplying every term by 2. Okay?
Okay.
Now notice that I can get a variable to go away by just adding these two equations.
The x goes away.
Yeah, in fact, I get y equals 35. Instant solution.
Okay.
Now to solve for x, I go into the simplest equation, substitute 35 for y, and go from there. X must be minus 60. Because a minus x plus a 70 has to equal 10. Whoops, x must be plus 60, excuse me. Because then it would be minus a 60 plus a 70 equals 10. So here's the here's the single solution to the two equations that I gave you. Now, when you're making up equations to give somebody, it's real simple. Just don't make the second equation resemble the first in any manner.
Okay.
When
You can only be switched.
Yeah, in other words, had I made the second one just a multiple of the first, that can't add any information. This had an infinite number of solutions all by itself. Well, these two equations together have to have the same infinite number of solutions.
Right.
If you go to solve this, you will get 0 equals 0, which is a true statement, but it doesn't tell you what x and y are, and that's because x and y, there's an infinite number of solutions.
That makes sense, because everything's just double.
Yeah, in other words, I haven't added a different equation when I gave you equation number 2. Now, I can make things much worse by changing this 20 into a 19. Now, the left side of this equation is exactly twice the left side of this equation, but the right side is not. So if I proceed to manipulate these, I'm going to get 0 equals 1, or some other number. That means no solution.
No solution. Okay.
So you can spot whether there's one solution, no solutions, or infinitely many by comparing the two. Usually you want to compare the entire left side with one another. And if you can see that this left side is a multiple of this, then the right side better be the same multiple. And then you'll have infinite number of solutions. If the right side is a different multiple, you got no solution. There's no number you could put over here to actually give you a solution. All right, what else you got?
Okay, 4x plus 5y equals -2. The other one is 5x minus 4y equals -23.
Notice these are completely different.
So there's probably going to be a solution.
Yeah, I would expect there definitely would be a solution. However, it's hard to get the variables to disappear. I can't add or subtract these and make a variable go away. So what do I have to do?
You would have to...
This is equation 1, this is equation 2.
And you can't combine them yet.
No, I could, but I'll still have two variables. In other words, I could add them, and I would have 9x plus y equals -25, but that doesn't help me any. The only way I can solve it is if I can get a variable to be eliminated.
Okay. Would you... But can you move, like, the y?
Well,
Or no?
it's not obvious as to how to do it, but what if I multiply equation number 1 by 4 and equation number 2 by 5? What does that give me? Multiply equation number 1 by 4, what do you get?
Okay, so you're gonna have 16x 20y equals negative 6
Negative 8.
or 8.
Okay?
I'm sorry.
It's all right. Now multiply equation 2 by 5.
Okay. 5 times 16.
No,
80?
equation 2.
Oh, I'm sorry.
All right.
Okay, by 5. So it'll be 25x minus 20y equals negative
115. Now,
150.
can you see why I did what I did? In other words, why did I multiply equation 1
Yeah,
by
'cause
4
you
and
can
equation
take
2 by 5? It created the same coefficient
20.
in the y term.
So you can cross y out.
Right. I can now add the two equations that I have. And I've got 41x equals minus 123. X is equal to minus 3. And now go back into the simplest equation on the page. Substitute that x of minus 3 in for x and then solve for y. Well, the simplest equation I see is up here.
Right.
So 4
So
times minus 3 plus 5y equals minus 2. Which is minus 12 plus 5y equals minus 2, which is 5y equals 10, which means y equals 2. There's your single solution. X equals minus 3, y equals y equals 2.
Okay.
Okay? So that was the hardest one we've done because we had to multiply both equations. In other words, with one multiplication only, I wasn't able to get the coefficients the same. And you either need to get the coefficients the same or just opposite signs. You got another one kind of like that?
I don't, but I have one that says, solve the following systems of equations using the graphing method.
Okay.
But I don't know if we can do that.
Sure. We got time to do that.
Okay.
Yeah. What are they?
Okay, it's 3x plus y equals 1. And then negative 9x minus 3y equals 3.
Notice the second equation is what relative to the first equation?
It's multiplied by 3. Or negative, multiplied by negative 3.
The left side is multiplied by negative 3, but the right side is multiplied by 3.
Okay.
Immediately, no solution. Because if I multiply this left top equation by 3, I get 9x plus 3y equals 3. Now if I add the two equations, I get 0 on the left side and 6 on the right. Since 0 is not equal to 6, must be no solution.
Okay.
But I didn't actually have to attempt to solve it to discover that. So all I had to do is notice that the left side is a multiple of minus 3 times that, but the right side is not. If that was a minus 3 like that, now it's not no solutions, it's infinite number, because I really only have one equation. It's the same one.
Right.
This equation is this equation times minus 3. So it's not really two equations. So
yeah, it tricked me when I saw the positive.
and if they said solve it by graphing, so we'll try. In order to graph it, let's put it into y equal mx plus b format. So the first one goes to this. Second one goes to this. Okay? Those both have the same slope. One has an intercept there, the other has an intercept there. A slope of -3 is like that. That's the first equation. Second equation is a parallel line. We know that if two lines have the same slope, they're parallel, right? Parallel lines never intersect. So this has to be no solution. If they ever intersected, we'd have a solution, and it would be wherever they intersected. So if you're solving something graphically, just graph both equations and figure out where it intersects, and that's your solution. Okay. But in this case, I can see real easily that graphing these two lines, I have the same slope, but different y-intercepts. So it's just going to be railroad tracks. No solution for railroad tracks.
Okay.
And if it was the same line like that, then it would just be one line only. And that would be the graph of both graphs would be one line, and one line has infinitely many solutions.
Okay.
So if you end up with only one line, you have infinitely many. If you end up with two parallel lines, you have no solution. And if you end up with two lines that cross, then that's the solution right there.
Okay, that makes sense.
Yeah. Let's see, we're going to 9 tonight?
Yeah.
Okay.
Unless you have any more.
No. I've had an extremely full day, so I'd rather just go to 9. You have a session tomorrow, or no, not till Thursday? Do you have a test tomorrow?
Yeah. I don't have a test tomorrow.
Okay. Why don't we go to 9 and then do an hour on Thursday at 7? Does that work for you?
Okay. Yeah, that's good.
Okay. Go ahead and give me another problem. We can keep going. I mean, I don't mind. If you want to go to 9:15, I can probably stand it.
Okay, that'd be awesome.
Okay, sure.
Okay, so this is a word problem.
Okay.
Is it okay? Okay.
Yeah.
It says, Ryan is in the band room when a new shipment of trumpets and trombones arrive. Before opening the boxes, he decides to figure out how many trumpets and how many trombones there will be. The bill shows that there was a total of 27 new instruments for a total of $10,950. By looking at the catalog, he can tell that each trumpet costs $350 and each trombone costs $475. How many of each type of instrument are in the shipment?
What was the cost of each trumpet?
Trumpet costs $350.
And trombones?
$475.
I guess dollar signs works better than degrees here, doesn't it?
Yeah. And it wants me to make list of variables, which would be X would be trumpets and Y would be trombones, right?
Yeah. Now, that's the first step of every word problem. If everybody did that as the first step, word problems would be so easy it's unbelievable. But nobody does. Everybody leaves out that first step and tries to do the whole thing without that first step. But the first step is define your variables. If X is the number of trumpets and Y is the number of trombones, now I can write some equations. I need two equations, right? Because I have two variables, so I'm going to need two equations to be able to solve it. What's one equation?
Because you're taking the trombones and the trumpets, so it'll be 350x plus 470, y equals $10,950.
Huh? What's the second equation?
Let's see, there are 27 instruments, so we can say x plus y equals 27.
Solve that system of simultaneous equations.
Okay, so would you do like what we were doing earlier with like the method?
Yeah. Now, remember, we can add or subtract equations. We don't have to always add them. So if I can make the coefficient in front of x be 350, then I'll just subtract the two equations and x will go away.
Okay.
So this is equation 1. This is equation 2. Let's multiply equation 2 by 350 to give us 350x plus 350y. What is 350 times 27? You have a calculator?
I can get one out. Give me just 1 second. Okay, 350
Times 27.
9,450.
So this is my new equation 2.
Okay.
Now what?
Would you subtract 350x and 350y?
Yeah, that gives you 0 there.
Yeah, okay. So then, then you would just do
How many y do we have?
Would you subtract the 475 from 352?
We're subtracting 350 from 475.
Oh, sorry, my bad.
It's all right. Because I could have gotten rid of the x by either method. But I like to keep positive coefficients instead of negative coefficients.
Right.
So that's why I want to subtract 2 from 1, not 1 from 2.
Okay. So would it be 125?
Equals what?
And you're going to take 10,000 minus the 9,000.
That equals 1,500.
Okay, 1,500.
So y is equal to 12?
I can double check that if you want me to.
No, that's right.
Okay.
10 times 125 would be 1250, and 2 times 125 would be another 250, so 1250 plus 250 would be 1,500. Now,
that's true. Okay.
I've solved for y. What's the best way to solve for x?
Take the more simple equation, which is number 2.
Okay, the original number 2.
So it'll be 12. So it'll be x plus 12 equals 27.
Correct.
And you can subtract it, so it'll be 15.
So x is 15. So, in other words, even after you've manipulated an equation, you can still use it to solve for the second variable. In other words, I haven't really killed this equation. I've just multiplied it by 350 and written it down again. But that doesn't prevent me from using the simpler one to solve for the second variable. And clearly that's the best way to do it. Now, there is a way to solve this problem with using only one variable. But I suspect that they want you to use 2 variables on it because this section is all about solving a system of equations, right?
Correct.
If I was going to do it by one variable, then I wouldn't use x and y. I would use x, and 27 minus x is the number of trombones. In other words, I take what would have been a second equation and I merely eliminate that y variable. I don't need it. I can solve this whole problem with just the x variable. Since I know they total 27, if x equals the number of trumpets, then 27 minus x has to equal the number of trombones. that's a little bit out of the box thinking and not the way they really want you to do it, but you can certainly do it that way. In other words, you can make this a one variable problem. You don't have to use two variables to solve it.
Okay.
Okay? It's just not something you need to worry about, but if somebody gave me this problem, I'm not sure I would use two variables. I would probably use the one variable method, merely because then I don't have to solve two equations and two unknowns. In other words, if I use x and 27 minus x, then this equation here is all in x, because this would be 27 minus x. And now, one equation, one unknown, I can solve it for x.
Okay.
Not trying to confuse you, but hopefully I didn't with that statement. Yeah. Got another word problem?
I do.
Let's do it.
Okay. It's Kathy and Keith went into the media store. Kathy bought 3 CDs and 4 DVDs for $113.90. Keith bought 2 CDs and 3 DVDs for $81.93. And it says use this information to determine the price of a CD and a DVD.
What was the first net at total? 3C plus 4D was what?
113 and 99 cents. Sorry.
99?
90 cents. 90.
It's all right.
Sorry about that.
No problem. Okay. Notice that I defined my variables on the fly as you were reading it. C was equal to the number of CDs. D was equal to the number of DVDs. Excuse me. That's not correct. C is the price. When you're defining your variables, it helps to define them as, are we talking the number of CDs or are we talking the price of a CD? Well, when you read the question, you said she bought 3 CDs and 4 DVDs for this price. So C must be the price of a CD, and D must be the price or the cost of a DVD. And that would give me these two equations. Right? In other words, the number of CDs times the cost of a CD plus the number of DVDs times the cost of a DVD will give you your total cost. Mm-hmm. Okay. And that's what they want to know, right? Is the price of each?
Yep.
You can always define your variables by looking at your last question in the word problem. The way to do word problems is start at the back. Always look at what they're asking for, and that's how you define your variables. In other words, they don't want to know how many CDs, they want to know the cost of each CD. So we're going to let C equal the price of a CD and D equal the price of a DVD. Now, I can solve this system of equations. This is a little similar to the 4 and 5 ones. How can I eliminate a variable?
Can't you multiply it by, or changing the symbols?
No?
No. Would you multiply like the top equation by 3?
Well, by itself, that won't help. Let's do it. What's 3 times that?
3 times 113?
Yeah, 0.9.
Give me just 1 second. Yeah, 341.7. Oh, sorry.
It's all right. Okay, now equation 2. What do I need to do to equation 2 so that I can eliminate a variable? What do I need to multiply it by? In other words, if I look at just equation 1 and equation 2 now, I get nothing to disappear, right?
Right.
By either adding or subtracting. So I have to manipulate equation 2 also. What can I multiply equation 2 by?
Oh, you can do it by 4.
Okay. Now that gives us 8c plus 12d equals, what's 4 times that number?
4 times that number? 1,300.
4 times 81.93.
Oh, I'm sorry, I was looking at the wrong number.
That's why I label these equations with numbers on the left, is because you're frequently looking at a lot of equations on the board. And it's real easy to get lost.
Right.
So I want to multiply this equation 2 by 4. So I got to multiply 4 times this 81.93. What is that number equal to? Connor? Connor, you still there?
Can you hear me now?
Yeah, I lost you for about...
Sorry about that.
It's okay. So what is...
Okay, it's
what is 4 times that number?
327.72.
Now we have a new equation 1 and a new equation 2. Let's forget the originals so we're not confused. Now how can I solve this set of equations?
Okay, so you would eliminate the d completely, so then it would be
By doing what?
Subtracting
Okay.
them, right?
That's an important thing to know, whether you have to add or subtract them. Because it affects what's going to happen with C and the number. In other words, the fact that I have to subtract these doesn't make 17C, it makes 1C. Equals 1398. You've just solved for the price of a CD. To solve for the price of the DVD, go up into this. This is the simplest of the original equations. In fact, this is the simplest equation on my page now. And substitute 1398 for C and solve for D.
Okay, so you do 2 times 13.98, right?
Which is 27.96 plus 3D equals 81.93. Now subtract 27.96 from both sides and divide that by 3. And you'll have the cost of a DVD.
Divide both sides, so the 27 and the 81 by 13.
First of all, you got to get the 27.96 on the other side. In other words, I'm solving this equation at this point.
Okay.
So
you would
subtract
okay,
27.96 from both sides.
93. It's 53.97.
Okay, so we have 3D equals 53.97. D is that divided by 3, whatever that is. So there's your cost of a DVD.
It's 161.90.
Try 16.
Or, sorry, I hit the
Okay.
multiplication button.
It's okay.
53.97.
Divided by 3.
Or what?
Divided by 3.
Okay. 17.96 $2.99.
There's the cost.
Sorry about that.
There's the cost of a DVD. All right, Connor, I think I need to be done.
Awesome. Thank you so much for your time.
Let's see, we will be meeting again Thursday at 7.
Sounds good.
Okay. Have a good night.
Okay, you as well. Thanks again.